அடுத்த நிகழ்ச்சியாக ஆடலரசி ஸ்ரீமதி செந்தில் செல்வி சுரேஸ்வரனின் உருவாக்கத்தில் ஸ்ரீ அபிராமி நாட்டியாலய மாணவிகள் வழங்கும் அகிலத்து ஆணிவேர் அம்மா. பங்கு பெற்றுபவர்கள் தர்ஷா ராஜலிங்கம், ஹிரண்யா யோகரத்ன ராஜா, அபினா மகேஸ்வரன், மினிஜா சோமசுந்தரம், அஷ்மிகா சுரேஷ், ஜானவி தனா, அயான் தனா, அஷானி சிவகுமார், ஷாலிகா வரதராசன், ஆதர்ஷா ஜெயச்செல்வன், சப்தனா ஜெயக்குமரன், நிருஜா ஜெயலிங்கம், சிந்து செந்தில் மோகன், அபிரா சிவகுமரன், மாலவிகா சின்னராசா, கீதியா ஸ்ரீனிவாசன், மதுஷிகா மனோரஞ்சித ராஜா, வைஷ்ணவி மகேஸ்வரன், அர்ச்சனா ஸ்ரீபதி, மாதரி செந்தில் மோகன், அர்ச்சனா ரகுரஞ்சன், ஆரணி மகேஸ்வரன், அனுஷ்கா பரத்வாஜ், லக்ஷிகா சின்னராசா, விதுஷா மனோரஞ்சித ராஜா, நர்த்தகி பிரணதார்த்திஹரன், சாஹித்யா சுகுமார், மீருஷா பிரேமகாந்தன், துஷாரா பிரேமகாந்தன், வீணுகா வித்யானந்தன், சிதாரா விஜயவரணன், ஹரணி சிவகுமார், சாய்மீரா யோகராஜா, பிரணவிகா சின்னராசா, ரிஷிகா வித்யானந்தன், நிவிஷா சிவச்சந்திரன், சுரனுதா திருப்பரன். தேசங்கள் மாறுபடலாம், கலாச்சாரங்கள் வேறுபடலாம், பருவ வளர்ச்சியால் பிள்ளைகளின் மனநிலைகளும் தழும்பலாம். ஆனால் அம்மா என்றவளின் அன்பும் அரவணைப்பும் ஒரு முடிவிலி. விதையில் இருந்து வெளிவந்து இலை வெட்டு செடியாகி கிளை விரித்து மரமாகி மலராலே நறுமணம் வீசி நிற்கையிலும் பின் பலமான காற்றாலே கிளை ஒடிந்து அழகிழந்து போனாலும் மண்ணுள்ளே தன்னை புதைத்து தன் மரம் சரியாது பலம் கொடுக்கும் அந்த ஆணிவேர் அவள்தான் அம்மா. இதோ அகிலத்து ஆணிவேர்.
A child is conceived in the womb. The child grows, but the child cannot breathe. The mother breathes for him. And for 9 months continuously, he hears the beating of the mother's heart. It is the first meeting with music and rhythm. That is the first drum one encounters. Om Shakti.
When the wind blows, the cradle will rock. கண்ணத்தில் முத்தமிட்டார் கண்ணத்தில் முத்தமிட்டார் உள்ளதான் கல்வரி கொள்ளுதடி கண்ணத்தில் முத்தமிட்டார் உள்ளதான் கல்வரி கொள்ளுதடி உன்னை தழுவிடிலோ கண்ணம்மா உன்னத்தமாகுதடி
கண்ணக ஜும் தரி கடக தக்க தித்த கண்ணக ஜும் தரி தத்தித்தம் தர்கட தக்க தித்தம் ததிம் தத்தகணம் தத்தக ஜும் தத்தஜம் தத்தரித தத்தனத தர்கடதம் 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 தர்கடதம்
கண்ணே கண்மணியே பூவே மயிலோ தூகை மயிலோ குயிலோ கூவும் குயிலோ நிலவோ நிலவின் ஒளியோ இமையோ இமையின் கனவோ
Mother is love. Mother is life. Mother is harmony. Mother is earth. Mother is all. Mother is rhythm.
அச்சாணி, முதுகெலும்பு, மூலம், ஆணிவேர். மிக அண்மையில் இந்த மொழி வல்லுநர்கள் எந்த மொழி உலகத்தில் முதல் தோன்றியது என்ற ஆய்வில் மிக அண்மையில் ஒரு முடிவிற்கல்ல, ஒரு முதலாக ஒரு உந்துதலுக்கு உள்ளாக்கப்பட்ட ஒரு விடயம் அம்மா. ஒரு குழந்தை பிறந்து வளர்ந்து வரும்போது எதுவித நா அசைவோ அல்லது வாய் அசைவோ இன்றி சாதாரணமாக வெறுமெனவே வாயை திறந்து பின் மூடி பின் திறக்கும்போது, ஒரு தடவை வாயை திறந்து திரும்ப வாயை மூடி மீண்டும் வாயை திறக்கும்போது அந்த அம்மா என்ற ஒலி மிக சாதாரணமாக வருவதால் தமிழ் உலகத்திலே முதல் தோன்றிய மொழியாக இருக்கலாம் என்ற ஆய்விற்கு வந்திருக்கின்றார்கள். அந்த வகையிலே ஆணிவேராக அம்மாவை சித்தரித்து இந்த அருமையான நாட்டியத்தை வழங்கிய மகாஜன கல்லூரி பழைய மாணவி இயல் திருமதி செந்தில் செல்வி சுரேசன் அவர்களை தற்போது மேன்மைப்படுத்துவதற்காக நாம் அன்புடன் மேடைக்கு அழைப்பது திரு ஜெகநாதன் அவர்கள். நன்றி. அடுத்த நிகழ்வுக்கு வருவதற்கு முன்னால் எமது இன்றைய விழா அனுசரணையாளர்களை ஒரு தடவை மீண்டும் பார்த்துவிடலாம். இந்த அரங்கத்திற்கு அனுசரணை வைத்திய கலாநிதி வி விஜயரத்னம் அவர்கள். தொடர்ந்து GMA GTA Square Mall காட்ரேஜ் விற்பனை சேவையில் முதன்மையாக திகழ்கின்ற அந்த நிறுவனம். தொடர்ந்து பிரிம்லி ரோட் வைத்தியசாலை, வீடு வாகன காப்புறுதி முகவர் செந்தூரன் புனிதவேல், Canadian Apartment Properties CAP Real Estate Investment Trust தரமான வீட்டு குடியிருப்பு நிறுவனம், Fashion and Fancy House, நந்தா உணவகம், காப்புறுதி முகவர் திரு பிரணவன் நந்தீஸ்வரன், சரன்டிப் டிராவல்ஸ் ஸ்தாபனம், காப்புறுதி முகவர் திரு வைரா கருணானந்தன், சட்டத்தரணி திரு ஜெகதீஸ்வரன், TE பிஸ்னஸ் டெக்னாலஜி காலேஜ் உரிமையாளர் அனைவருக்கும் மகாஜனா கல்லூரி பழைய மாணவர் சங்கம் தனது நன்றியை தெரிவித்துக் கொள்கின்றது. நன்றி.
Next, we will have Mithunan Ravindran. Mithunan Ravindran is the son of Mahajanan Dr. Ravindran Karthigamasekharam. He will be going into grade 12 and currently serves as the Secretary General of the Southern Ontario Model United Nations Assembly, one of the oldest and most prestigious model United Nations conferences in North America. He also has an avid interest in neuroscience and now works in a Sunnybrook Hospital lab researching possible cures for Alzheimer's disease. Let's welcome Madhunan Ravindran on stage.
Good evening, ladies and gentlemen. Tonight we have gathered to celebrate the achievements and the success of Mahajana's youth. For this reason, tonight's keynote speaker is an especially appropriate choice to address this audience. In a few moments, we will be hearing a presentation from Abhikumran Uttamakumran, a young person who has made great strides in the field of cancer research. Abhikumran's journey to the medical sciences has indeed been a long one, beginning at the tender age of 3 when he played with a toy stethoscope. Since then, his career has progressed in leaps and bounds. Abhikumran has dedicated years of study to build his scientific knowledge, and recently he theorized that the chaotic behavior of cancer cells could be regulated through the use of proteomic clusters. This was a profound shift in the cancer treatment paradigm that has existed for years. When trying to find a platform for his work, Abhikumran was turned away by 49 researchers. However, Dr. Philip Gold, one of Canada's leading cancer researchers, as well as a professor of physiology and oncology at McGill University, provided him with the opportunity to further explore his ideas. Of course, Abhikumran is best known for his scientific accomplishments. However, there have been a number of other factors that have affected his trajectory in life. Abhikumran has studied Tamil literature, as well as Hindu scriptures and the Torah, and all of these have allowed him to create a holistic view on the arts, the sciences, and the connections between them. This aspect of his studies has also helped shape his ideas concerning cancer research. Over the years, Abhikumran's exploits have not gone unnoticed. He has been honored with a number of prestigious awards, including the Governor General's Medal, where he greeted the Duke and Duchess of Cambridge, the McGill Dean of Sciences Distinction Award, as well as the Minister of Citizenship and Immigration's Anti-Racism Campaign Award. Abhikumran is currently pursuing a joint MD and PhD at McGill University. Tonight, Abhikumran will be presenting a topic with which he is intimately familiar, the history of cancer. He will also be talking about his own research as well as preventative methods. Now, ladies and gentlemen, without further ado, please join me in welcoming tonight's keynote speaker, Abhikumran Uttamakumran. Please, ladies and gentlemen, a standing ovation for our keynote speaker.
அனைவருக்கும் எனது வணக்கங்கள். எனக்கு தமிழில் பேச தான் பிடிக்கும். இங்கு இருக்கும் அனைவரும் தமிழர்கள், நானும் தமிழன். ஆனாலும் அனைவருக்கும் இங்கிருக்கும் சிலருக்கு தமிழ் விளங்காத காரணத்தினால் நான் ஆங்கிலத்தில் தான் அதிகமாக பேசுவேன். ஆனால் முக்கியமான கருத்துக்களை நான் தமிழில் கூறுவேன். அதனால் குறையெடுக்க வேண்டாம். நன்றி. So welcome, ladies and gentlemen. I'm very proud to be here tonight because my mother was also an old student of Mahajana College, and it is with great pride that I'm here, and I will begin the presentation. So cancer, is it a disease or a defense mechanism? பொதுவாக புற்றுநோய் என்ற பெயரை கேட்டால் எங்களுக்கு ஒரு பயம் வரும். அது ஒரு தீய சக்தியாக தான் நாங்கள் நினைத்து கொண்டிருக்கிறோம். We normally think of cancer as a very negative disease, as a negative factor that contributes to a high rate of deaths, mortality amongst us. But what really is it? How did it emerge? What would you do if I actually told you that cancer was actually a defense mechanism in the human body, which just got recently modified about 5,000 years ago? Until then, this disease, or the genes correlating to the disease, were actually the contributors to a prolonged life. நான் கூறுவது என்னவென்றால், இந்த புற்றுநோய் கலங்களுக்குள் இருக்கும் பிற சத்துகள், அதில் இருக்கும் இந்த மாற்றங்கள் நல்ல விஷயங்களை கூறினன. அதாவது நாங்கள் அதிகமாக வாழ முடியும் என்பதை எடுத்து காட்டுகிறது. எங்களது முன்னோர்கள் கிட்டத்தட்ட 2000 வருடங்களுக்கு முன்பே அவர்களோட இந்த மாற்றங்கள் ஏற்பட்டதால் அவர்கள் வாழக்கூடிய அந்த தன்மை குறைந்து வந்துள்ளது. ஆனால் 4000 5000 வருடங்களுக்கு முன்பு நாங்கள் பார்த்த பொழுது முந்திருந்த மானிட பிறவிகள் கிட்டத்தட்ட சுமார் 400 500 வருடங்களுக்கு மேல் கூட அவர்களால் வாழ முடிந்த அந்த தன்மை இருந்தது. ஆனால் அது இப்போ அழிந்து விட்டது. அதற்கு என்ன காரணம்? அந்த வரலாறு என்ன? That will be the presentation of the beginning of the presentation tonight, and then I will proceed into the further insight of my research. Thank you. So human evolution, where did it begin? According to evolutionary biology, we began as this individual here, right? The chimpanzee. Well, the main concept is that we all derive from a very unicellular organism. இங்கே இருக்கும் அனைவரும் ஒரு சிறு அணுவிலிருந்து ஒரு கலத்திலிருந்து தான் நாங்கள் அனைவரும் உருவாகியிருக்கின்றோம். We all like to divide ourselves as different individuals. Oh, I am such person, this one is from this individual, etc., etc. But the truth is that we all derive from one microscopic organism. And this is derived from every religion. அனைத்து மதங்களிலும் இதை தான் கூறுகிறார்கள். Whether it's the Bible or whether it's the Hindu scriptures, it's just a term of conscience. For instance, if you were to take the Bible and literally believe in every word it says, it refers to the creation of the universe in terms of days. But for in today's society, a day is 24 hours. But perhaps a day could refer to a couple of years or a different time frame. நாளிகை என்ற வார்த்தை இந்த ஒரு நாள் என்று நாங்கள் எடுத்துக்கொள்ளலாம். ஆனால் முன்னோர் காலத்தில் நாளிகை என்பதற்கு உண்மையான அர்த்தம் எங்களுக்கு தெரியாது. The time reference is the key point. But in terms of an evolutionary time reference, it's very short. And we went from here all the way down to the Homo sapien. Now this is where the problem begins. Because when this guy here emerged, there have been mutations. Now what do I mean by mutations? I'm going to show you. So this has been actually referred in many ancient scriptures. Many people have studied cancer in the past. One of the earliest researchers in the field of oncology, in the field of cancer, is actually the Egyptians. The Egyptians were actually successfully able to treat eye cancer, uveal melanoma, ocular tumors, and etc., with natural ingredients such as honey. There have been papyrus scriptures in hieroglyphics indicating that honey and other natural berries were used to suppress tumor in the eye. And in fact, they were even able to associate diseases of other organs with eye cancer. They were able to track down that metastasis, which is the spreading of cancer from one organ to another, forming secondary tumors. They were able to map down that eye cancer can actually go to the liver and further spread in the body. நான் கூறுவது என்னவென்றால் 4000 வருடங்களுக்கு முன்பே இதை பற்றி பல ஆராய்ச்சிகள் செய்துள்ளனர் எகிப்து நாட்டில் முக்கியமாக. And even further than that, we have evidence of suppressing cancer, but it's not referred to as cancer, but it's referred to as abnormal masses, abnormal tissue clusters. And this has been actually written by one of the well-known Hindu authors known as Vedavyasar. வேதவியாசர் எழுதிய பழைய நூல்களில் முக்கியமாக பல புராணங்களை 18 புராணங்களையும் எழுதியுள்ளார். 4 வேதங்களையும் தொகுத்து உருவாக்கினவரும் அவர்தான். இன்று எங்களுக்கு அந்த 4 வேதங்களும் இந்து சமயத்தில் இருக்கிறால் அதற்கு காரணம் வேதவியாசர். அவரின் அந்த 4 வேதங்களில் 4வது வேதம் அதர்வ வேதத்தில் இருக்கிற ஒரு பகுதி தான் நாங்கள் இன்று ஆயுர்வேதிக் மெடிசின் ஆயுர்வேதம் என்று கூறுகிறோம். அதிலும் புற்றுநோயை பற்றிய விளக்கங்கள் இருக்கின்றன. ஆனால் அது இன்றைய விஞ்ஞானத்துக்கு தெரியாது. Which is the funny thing. So the question really is it science or non-science? What is the real boundaries? கண்ணால் தெரிவது மட்டும்தானே உண்மை என்றால் கண்ணுக்கு தெரியாததெல்லாம் என்ன? The things that we can't see, what is it? Does that mean that just because you can't explain it with the terms of science that we have today, does that mean that does not exist? This is the real science. The real science is the things that we cannot explain. I normally refer to a quote by Karl Popper, a philosopher. He said that science should not be based on validity, but it should be based on falsifiability. And this clearly indicates that. And the roots to science is, one of the biggest problems today with science is that we like to linearize things. Everything becomes linear. நாங்கள் விஞ்ஞானத்தில் அனைத்தையும் ஒரு பகுதியில் வைத்து தான் பார்க்கின்றோம். Everything is reduced. But the real global approach is to look everything in a universal aspect, which indicates that all fields other than the sciences, whether it be the arts or whatever it is important and is critical to the understanding and further development of the sciences. Which is why it is highly recommended that everybody pursues whatever they wish, whatever career you wish to pursue in, embrace that. It's going to bring you to high success. I'm just going to check the time because I don't want to go in a time rush, but I'll try to quickly go over it as much as possible. So the question is, what's good versus bad? Good versus evil. It's been a concept that's existed for many years in everything, from religion to politics, etc. And this exists in the cellular environment as well. நன்மை தீமை என்ற அந்த வித்தியாசம் கலங்களிலும் இருக்கின்றன. புராண கதைகள் நாங்கள் கூறுவோம், அசுரனை தெய்வம் வதை செய்தது, சாத்தானை ஜேசுநாதர் வந்து சண்டை போட்டார், அப்படின்னு பல கதைகளை நாங்கள் கூறுவோம். ஆனால் அதற்கு உண்மையான காரணம் என்ன? Don't take it in literal terms. Now let's look at it in the microscopic level in terms of cells. Sorry. What you have here is the imagery of a misbehaving child. குழப்படி செய்யும் ஒரு குழந்தை. Does that mean that just because the child is misbehaving, we have to kill the child? Destruction is not the solution. What are we doing today in cancer research? Yes, it's progressing. We're going into many scopes and there's many findings. But if you notice, a lot of the treatments that we're using, such as radiation therapy, chemotherapy, கதிர்வீச்சாக இருக்கட்டும், நாங்கள் கொடுக்கும் மருந்துகளாக இருக்கட்டும், புற்றுநோய் ஆராய்ச்சியில் இன்றைக்கு நாங்கள் பயன்படுத்தும் முறைகள் நல்ல கலங்களையும் புற்றுநோய் கலங்களையும் பாதிக்கின்றன. அதற்கு ஏன் காரணம் என்றால் அழிவு தான் அதற்கு தீர்வு என்று நாங்கள் நினைத்துக் கொள்கின்றோம். ஆனால் அழிவு அல்ல தீர்வு. Behavior is alterable. You can change behavior. There's a new definition to tumor cells now. That's what I'm going to show you. A misbehaving child, if you teach the child to behave properly, the bad child will turn into a good child. Very simple concept. It exists in nature. இயற்கையில் இருக்கும் ஒரு சிறிய விஷயம் தான் இது. Everything, when there's a positive, there's a negative. Everything has an alter ego, right? Positive attracts negative. Newton's third law, right? Every action has a reaction. Newtoniன் மூன்றாவது விதி. It's been all said, but we all think of it in linear terms. We're all stuck into a very little paradigm that we don't like to look outside of it. And that's the key problem with creativity, which is why Einstein said, question as much as you can. கேள்வி கேட்பது நல்லது. So I'm going to show you how we used to look at cancer. This is the terms for cancer before. So we used to think that in our DNA, if there's an error or if there's a mutation, if there's something that causes an alteration in the sequence, so basically the genetic material within us, within every cell, we all have it, right? If there's an alteration in it, because of some kind of environmental factor, because of our diets, because of radiation, because of smoking, etc., 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 it causes random behavior. And we used to say that it's because what it does is it interferes in its normal functioning, therefore it leads to abnormal cell division. அதாவது இப்படிப்பட்ட மாற்றங்கள் கலங்கள் பிரிவதை அது பாதிக்கின்றன. Right? Abnormal cell division. That's the old definition of cancer, and I'm going to show you how it's been changing. Right? So this is how, it's not really, it's just a general approach, just to show you what I mean by the differences. A normal cell would have a normal round-like structure or whatever, an animal cell, of course, depending on the pathology and the histology of the individual cells, from what organ it derives from, it has different characteristics. But you would see a normal nucleus, the center of the cell, and it would have normal behaviors. The membrane is normal. But you see, you know what the problem is? In cancer, we're all focusing over here. Notice that in the cancer cell, it's going to have an abnormal structure, and the nucleus gets bigger normally, and the DNA is just mutated. But what are we all doing? We're all only focusing in the inside. நாங்கள் அனைவரும் பார்ப்பது தனி அந்த இடையில் இருக்கும் அந்த நியூக்ளியஸை மட்டும்தான். But have you noticed that? But it's also the membrane, the outer membrane that is abnormal. So why are we targeting the genetics? Why are we targeting the nucleus and not targeting the outside? I mean, it's a very simple concept. In order to enter the nucleus, you have to go from the outer membrane and then get inside. So why would you directly aim for the nucleus when you can't fix the outer membrane? It's because logically we think that, it's because of the genetic alterations and the genes inside is what regulates the outer membrane, but that's not the key. There's so much complex biochemistry that develops on the outer membrane, which makes it the key, right? When you want to enter a house, you can't just aim to bomb the house and just go in. You have to walk through the doors and get inside the house, right? So when we have that simple logistic, why can't we apply it to the microscopic level? It's a very simple question. So here's the problem. We say that this is normal cell division, it goes in a normal rate, and in cancer cells, it just abnormally divides. And one of the biggest problems with cancers is that 90% of the deaths caused by tumors or cancers is that because of its spreading, which is what you call metastasis, I explained it. And there's two commonly known pathways. One is through blood vessels, and the other one is through lymph nodes. ரத்த நாடிகள் மூலமாகவும் lymph நாடிகள் மூலமாகவும் இந்த கலங்கள் பரவுறதுக்கு வாய்ப்பு இருக்கின்றன. So there's two common genes that we refer to. One is the oncogenes, which is believed to be the genes that cause cancer. So in our DNA, we have certain genes called oncogenes. There's so many of them. There's RAS, there's Chi, there's CRAC. There's so many of them. I can name on and on and on. There's about 30,000 genes, and each one has different metabolites, and this brings into millions and millions and millions of molecules. But that's not the problem here. Another one is tumor suppressor genes. These are genes that we have in our DNA as we speak right now. And these genes, what do? They try to prevent the occurrence of cancer. So when a mutation occurs, when something abnormal occurs to the cell, it tries to revert that process. It tries to prevent it from occurring. But you know what's the tricky part of it about these genes? When a tumor suppressor genes get mutated, it also leads to cancer, which is also very tricky. So that's metastasis. You have the tumor cluster, it's going into the blood vessels and it's going to spread to different organs. And normally when it spreads outside from that primary site, based on where it enters, it can lead to fatal symptoms, right? You have the tumor, it goes in and it's spreading. Now, I'm going to talk a little bit about my research. So what is the research that I'm doing at the moment? The research that I'm doing, we're trying to show that we had a notion that when there's a mutation in the genetics, you cannot revert it. It's not reversible. But everything is reversible. Everything can be fixed. And that's where our research brings us. And the fact that you don't need to kill cancer cells to treat them, but you can change a cancer cell. You can convert one into a healthy cell. That's the idea we're aiming for. It's called pre-selective morphogenesis. And I'm going to quickly explain. I'm not going to go into very complex terms in terms of the biochemistry or whatever. If you have any further questions, you can come and refer to me, and I can explain it, whether it be in whatever language it may be in, of Tamil, French, or English. Okay? So the research that I'm working on, we discovered a novel protein cluster. It actually came to me at the age of 13 from a very simple idea. I said, cancer is not abnormal cell division. It's abnormal cell behavior and primarily abnormal cell adhesion. Let me explain to this. அதாவது நான் கூறியது என்னென்றால் புற்றுநோய் அந்த கலங்கள் பிரிவதனால் வர பிரச்சனை அல்ல, அது ஒட்டுற விதம், ஒன்றும் ஒட்டுவதில் அல்லது சமுதாயத்தில் ஒட்டுற விதத்தில் உருவாகிற பிரச்சனை தான் புற்றுநோய். Let me explain to this. I'm going to do a quick demo. For instance, if I want to walk from here to that point over there, right? Or since there's an X right here, I'm just going to walk to the X. Right? If I want to walk over there, notice that my leg needs to adhere to the ground in order for me to take my next step. And if you remember from what I said before, 90% of the fatality associated to cancer is because it spreads. So if my leg needs to stick to the ground in order for me to move, so do cells. Cells need to adhere, they need to stick to their environment, to their matrices, extracellular matrices, their whatever it may be, in order to migrate. Cell migration cannot exist without cell adhesion. That's the primary concept. A very, very basic concept, right? So we started targeting these adhesion molecules. And one by one, after so much elaborate research, we discovered that there was a combination of 23 proteins that when activated, it releases a molecule that is hidden within inside the cell. நான் கூறுவது என்னென்றால் இங்க இருக்கும் அனைவருக்குள்ளும் ஒரு பிரத சக்தி இருக்கிறது, ஒரு புரோட்டீன் இருக்கிறது. ஆனால் அது இப்போ மறைஞ்சிருக்கிறது, அதை கண்ணால் பார்க்க முடியாது. இப்போ இருக்கும் முறைகளாலும் வைத்திய முறைகளாலும் அதை கண்டுபிடிக்க முடியாது. It's deactivated. But just because it's hidden, like I said, கண்ணால் காண முடியாதெல்லாம் நிஜம் இல்லை என்பது இல்லை. அதே மாதிரி தான், just because we can't see it doesn't mean it does not exist. So there's a concept called the loop effect. When you activate these 23 proteins, it releases this protein that is hidden. And when that protein is activated, you can extract this protein, you can amplify using technological procedures, and you can reintroduce it into the patient. And we've been doing clinical trials, and we started with 23 patients, and we went all the way down to 500 patients. And when we introduced this protein, which we call the AB complex, we realized that it did something remarkable. What it did was, it indicated that the reason why we have cancer is actually a defense mechanism of our body to not survive for a very long period. It is actually something that reduces longevity. And I'm going to show you how that works. So the molecule that we design, you can see that the orange globule that you see here, that's the targeted protein. And once we extract it and we inject it back, it's going to bind to all the cells in the body. உடலில் இருக்கும் அனைத்து கலங்களுக்கும் இந்த பிரத சத்து செயற்படும். அது சேர்ந்தவுடன் உடலில் இருக்கும் அனைத்து கலங்களையும் அது மறுபடியும் ஒரு நல்ல நிலைமைக்கு கொண்டு வரும். புற்றுநோய் கலங்களை மறுபடியும் நல்ல கலங்களாக மாற்றுகிறது. அது என்னவென்று இப்போ நான் காட்டப் போகிறேன். So these mice, I hope it was a bit more clear. The resolution is not so great. நேரம் okay? Okay. I'm going to quickly rush it through. So this mouse over here has a gastronoma, it has a gastric cancer. As you can see, it's not very clear, but its bowel is enlarged because there's a huge tumor mass. And because of the tumor, the eyes are also affected, and its ears are affected, and many regions of the mouse are actually infected. It's a metastatic tumor, means the cancer has spread. வயிற்றில் இருக்கும் ஒரு புற்றுநோய் அந்த கலங்கள் வந்து வெவ்வேறு உறுப்புகளுக்கு பரவி இருக்கின்றன. After the injection, post-treatment, in 40 hours, you see the transformation of this mouse into a healthier version with the eyes red and the bowel is back to normal. So we wanted to go into further details of what was going on. So here's what we call a survival curve. It's a simple procedure. We map down the survival rate of these animals before treatment and post-treatment. So prior to the treatment and after the procedure has been done. So what you have over here is the survival rate of the mice, the survival rate of an organism without exposure to the AB complex. And what you should see is a decline, right? And this is for something as very simple as the presence of one tumor cell. If it divides, and what's going to happen. So survival goes down. But with the treatment, it's at the 100% borderline and it hasn't dropped. So we were suspicious why this is occurring. So does that mean we have a cure for cancer? So we wanted to go further into it. So what we decided to do next was to test it upon human tissue lines. We did confocal test. We observed it under specific patients and what kind of alterations it had on their tissues. And as you can see over here, this is the image of a tissue sample from a woman who has breast cancer, மார்பில் இருக்கும் புற்றுநோய். அந்த நோயாளியின் கலங்களை தான் இங்கு காட்டுகிறேன். She's in stage 4, நாலாம் பகுதி. Stage 4 is is one of the last critical stage of cancer. It's the stage where the cancer has spread and it's in a very risky condition. And as you can see, within 84 hours, with 30 milliliters of the protein injected into the patient, 30 milliliter AB complex மருந்தை அந்த நோயாளிக்குள் செலுத்தியவுடன் கிட்டத்தட்ட 84 மணித்தியாலத்தில் இந்த வித்தியாசங்கள் தெரிகின்றன. Before treatment, the cells are very abnormal, they have chaotic processes, they're indicating very toxic properties. The cell physiology is completely abnormal, they're dead, they're shrink, they're shriveling, and then after treatment, as you can see, they're back to normal, they're healthy, there's clear blood supplies, angiogenesis has been inhibited, and the blood vessels started pumping in clean blood. So that's the transformation. And then we did a drug profile of the possibilities of this treatment in as many cancers as possible. And we discovered that at the moment it's working on 114 different types of cancers. 114 விதமான புற்றுநோய்களில் இந்த மருந்து வேலை செய்கிறதை நாங்கள் கண்டுபிடித்திருக்கின்றோம். From breast cancer, pancreatic cancer, leukemia, brain tumors. So what am I trying to tell you? I'm trying to tell you that it's not specific to any cell type. And that's what we want. We don't want a treatment that only works on a specific type of cell because of its profile. But it functions in every cell the same way. And that's the kind of treatment we want. That's what we're looking at. We're looking at in red, you can't see anything, because what the red indicates is after treatment, the activity of the cancer, and before treatment is indicated by blue. And as you can see, for each cancer, lung cancer, breast cancers, adenocarcinomas, etc., it's very high peaks. And then after treatment, it's all at zero. And that's what you see here. Before treatment, it's not very clear, but the cells, as you can see, they're very sticky, they're very adherent, and you see that by their morphology, by their structure. They're spread out, they're bigger, and they're sticking to their plates. And then after treatment, as you can see, all the cells are starting to clump up. They're all becoming rounder, and they don't have enough nutrients. And if you ask an expert, what does this indicate? They're going to tell you, oh, these cells are cancer cells, they were spreading, they were moving, and then after the treatment, the cells are beginning to die. But that's not the key. Just because it's beginning to look like that, it does not mean death is the solution. What this is indicating is that the cells look like they're about to die, but they're just losing their adhesion, they're losing their stickiness. And once they're losing their adhesion, it's actually going in, the molecule is entering their genome and transcribing this new protein and enabling a transformation, which leads to this cancerous to healthy alteration. And you see that, here's another example. Lung cancer of a metastasized patient. This was actually taken from I can't mention specific details about the individual, but he was a 69-year-old suffering from lung cancer, and he has never been exposed to smoking or any behavior of that sort, but still he developed a rare form of lung cancer, and within treatment in about 84 hours, back to normal morphology of the lungs. So with that, this is the results prior to treatment, with treatment at 100%, and when we gave sugar pills to test that it was not because of it's a procedure, it's a placebo effect test, and there was merely any indication. And here's a comparison. The lines are not so great, but here's a comparison of other drugs that we use in cancer therapy. So here's a HER2-dependent tumor, and we were testing the comparison of Herceptin, a drug that is commonly used in oncology, with the AB complex, and Herceptin still has only about an 80% survival rate. இப்பொழுது நாங்கள் பாவிக்கும் மருந்துகளுடன் கிட்டத்தட்ட 80% வாய்ப்பு தான் இருக்குது அந்த நோயாளி உயிர் வாழ்வதற்கு. ஆனால் நாங்கள் கொடுத்த மருந்துக்கு பின்பு 100% போய் உள்ளது. A 20% increase. So what are the side effects? I'm sure that's the question that's coming in your head right now. So yes, within 84 hours you see all these positive effects, but what are the long-term side effects? We've been screening these patients for now, it's almost 2.5 years. And there's been no negative side effects other than these frequent urination. They tend to get tired for the first couple of days because of the exposure to the new protein complex. Their sleep cycles, or REM sleeps, have been slightly altered for a while, but nothing extreme. And these are good indications because the frequent urination is actually because of patients who had cancer in the bowel or the urinary tract, the GUT, and they had to expel it. Some of the cancer cells were actually expelled when there were large tumors from the urine. So it's not a negative thing. So what are the side effects? Now this is the real truth. This is the thing that I want all of you to know here. The real side effect is the good positive effects of it. தீமை என்றால்தான் பிரச்சனை என்று நினைக்கிறோம், ஆனால் நன்மை அதிகமாக நன்மை உருவானாலும் அது ஒரு பிரச்சனை தான். So the side effect is that when you inject this drug into healthy cells, பிரச்சனை புற்றுநோய் இல்லாத கலங்கள், ஆரோக்கியமாக இருக்கிற கலங்களுக்குள் இந்த மருந்தை செலுத்திய போது, their behavior became extremely, how do you say this? Physiologically, biochemically more active. What I'm trying to say is that, as I said, evolutionarily we lost this mechanism, and once it was reintroduced into the body, it started doing two things at the biochemical level. Number one, our DNA is packed into these things called chromosomes, which we have in our cells. And at the end of the chromosomes, you have something called telomeres, the small unit of chromosome. And as we age or as cells divide, the telomeres, they get shorter and shorter. As they get shorter, therefore, the theory of aging, right? What the drug did was it re-lengthened the telomeres. So the telomeres got re-lengthened, number one. Number two, mitochondria. It's a part of the cell that actually is it's highly essential for the energy in our body, for producing energy, for the activation of all essential biological mechanisms. The mitochondria, it's the fuel center of the cell. Its activity got boosted about 100 times. It was a lot more rapid. So what's happening? Anti-aging. இந்த மருந்தை சோதித்து பார்த்த நோயாளிகள் உடனடியாக இன்னும் இளமையாக தோற்றமளிக்க தொடங்கிவிட்டனர். There was a 60-year-old woman who had wrinkles, and post-treatment, I cannot show you pictures because it's highly confidential, but the wrinkles started to disappear after the treatment. Why? It's a very basic concept. Why do wrinkles form? There's multiple reasons, but there's multiple explanations, but one of the major factor is the matrix, the tissues underneath, they're becoming weaker, so the collagen fibers are going down. I'm not going to explain the science. If you want further explanation, come and ask me after, but it's getting weaker. But now after we injected this drug, and we know that this drug stimulates all these molecules, all these structures started to redevelop. And therefore, the woman started to appear younger. A 60-year-old woman starting to look like a 40-year-old woman is not a joke. So that's one of the side effects. And yes, it's silly, but I have to mention that it's a side effect for the pharmaceuticals or for whatever it is. Under these notions, we have to refer it as a side effect, and the side effect is longevity. And we see this in any type of tested cell, pancreatic cells, gastrointestinal cells, thyroid cells, regardless of what type of tissue we tested the drug on, it started to show an increased biochemical activity in positive terms. Very quickly, in 5 minutes, I'm just going to tell you what you have to do. Now, what I'm here to tell you is that your medical profile is in your hands. You do not have to rely purely on the system, on on allopathic medicine in order to take care of your health. You have to command, you have to take priority, and you have to demand the services. That's the key. Each one of you have to behave as a doctor, as a medical practitioner. That's the key here. Just because we don't have a scientific background does not mean that we cannot take priority in these kind of references. So do your annual blood tests. Once in a while, you have to do your blood tests. They actually indicate many kind of factors, because we think that all these micro changes in these hormones or whatever are just whatever. Sometimes you take your blood report and it indicates, oh, your creatine levels are low, your whatever molecule is low, this one is high, your erythrocytes are high, and your doctor's like, oh, I'm not really sure what's really going on, but it's okay, it's nothing. Don't leave it. Do the research. Go on. We have Google. You just type it in. It's going to give you tons of pages. Spend your time and go into the research. And you have to find the links. And if you can't do it, just try to look for the correct resources and try to find a solution to it. Just don't leave it like that. Because one of the early indications of cancer is nothing. Pain. Some people get pain. We get pain in our head and we're like, oh, தலையடி தானே அதில் ஒரு பிரச்சனையும் இல்லை என்று நாங்கள் விட்டுட்டு கிடக்கிறது. ஆனால் அதுதான் பின்பு இன்னும் போக போக காலங்கள் செல்ல அது அந்த பிரச்சனை முட்டி வேற பிரச்சனைகள் எங்கள் உடலில் உருவாகின்றன. அதை நாங்கள் தவிர்க்க வேண்டும். அதுக்கு நீங்கள் பொறுப்பெடுக்க வேண்டும். So do your blood tests, do your urine tests, do your pap test, do your endoscopy. I'm mentioning all these techniques, and by a raise of hand, very quickly, how many of you within the past, let's say 6 months, have done this regularly? Look at the hands around you. So whatever it is that you require, mammography must be done for women above the age of 40, especially women around the age, in their menopause period must do a mammography just to make sure. And we actually have the techniques to do what you call gene profiling. You can actually take a sample of your DNA and look at all the genes that are activated and see if it can lead to any diseases in the future. A recent actress by the name of Angelina Jolie has actually done that, which led to her mastectomy. And colonoscopies must be done in all men above the age of 50 to make sure that they don't get colorectal cancers, because polyps can form. And this is also very important for the Tamil population because of the foods that we consume, very high in lipid profiles and cholesterol levels and high in spices. This is a very important thing for polyp formation. So for the men here, you need to do a colonoscopy. Right? So there's multiple techniques out there. Yes, it's not easily available. Even to go in and ask for an MRI scan, do you think you're going to get an MRI scan? No, it's very expensive. They're going to say no. Even getting a CT scan is sometimes very difficult. But you must demand your services. You must take your health as your priority. That's what I'm telling you. I'm not telling you to be paranoid. I'm not telling you to go crazy and increase your thoughts and go 10 steps. That's not what I'm telling you. I'm telling you to take care of yourself. Don't rely on the outside. Believe in yourself. That's what I'm trying to tell you. There's many screening methods, EKG, EEG, all these techniques that we have are indications. So I'm just gonna quickly end with one word here, rices. Rices. Adisi soda. I'm not saying rices because I'm brown. I'm saying rices because it's an acronym that I developed so that you can easily remember. R, radiation. I, inactivity. C, carcinogens. E, epigenetics and environments. Epigenetics is very important. Why am I saying that? What is epigenetics? I and another individual can have the same gene expressions to a certain level, but the genes will not behave the same way. Just because two individuals have the same gene, and whether they're activated or deactivated does not mean that they're going to be as sensitive. We're all different individuals, we all have different characteristics. The genes behave the same way. The microscopic part of us behaves the same way as the macroscopic structure. So the genes, their metabolites or their gene expressions can be, that are mimicked by each individual is not the same. Which is why sometimes we hear about an individual who smokes for 80 years and he's completely healthy, and we hear about another individual who had no such risky behaviors and developed cancer at a very early age. Epigenetics is one of the reasons. Because of the environment, ang samudayam, nangal சாப்பிட்ற உணவு பொருட்கள், நாங்கள் செல்கின்ற இடங்கள், இது அனைத்தும் எங்களுடைய உடலில் பெரிய பெரிய பாதிப்புகளை ஒவ்வொரு நொடியும் உருவாக்கின்றன. And also stressors, stress. Oh boy, stress. By a raise of hands, how many of you actually stress on a daily basis? You don't need to raise your hand because I know you all do. Even if you think you don't, your subconscious mind is actually stressing at the moment, but I'm not going to tell you that because you don't know that, right? And in 2 minutes, I'm just going to quickly indicate for the younger generation out there who like to be attached to their technological devices. Yes, I solely believe on technological devices for my presentations and my work, etc. as well, but there's a limit. I need to take precautions. Number one, game consoles and computers. The distance between your eyes and these devices can actually cause cancer. Here's an indication. These are retinal cells taken from mice that were exposed to the computer screen for a very long time. And as you can see, all these extremely bright clusters indicated, they're indicating cell death, apoptotic activity, because of too much computer screens. And this can lead to eye cancer. And even if it can't lead to eye cancer, it can develop other cancers around the areas. And that's what you see here. As the distance increases, the rate of cancer decreases as well. Televisions. When you watch too much TV, this is actually a different level. Sometimes you've been watching television for a very long time, and then you go to sleep, or even worse, you watch TV all night. And we like to do this in the summer, especially the kids. Oh, it's summertime, I don't need to go to bed early, and I'm watching TV all night. And in the morning, your mom comes, she looks into your eyes, and she's like, oh, your eyes look red. And you're thinking, oh, I didn't have enough sleep, I'm very tired, so I see these tiny little blood vessels popping in. Here's what's happening at the microscopic level. So here you have normal epithelial cells of the uveal epithelium of the eye, and then after exposure to EFL radiation from televisions, after a prolonged period, you see all these bloodsheds inside. And notice that the cells looking normal here are looking very chaotic here. These are actually indications of pre-initial conditions that lead to diseases like cancer. So it's your daily activity. Cell phones. Look at the damage that cell phone does on your thyroid glands and your salivary glands. And also your brain cells too. And it's a very simple concept. When I'm talking on the phone, let's say the signal from the satellite is actually coming from here, and the phone is in this hand. What does it have to do? In order to reach the phone, the signal has to come through my brain and then reach the phone, right? It's a linear mechanism. So you're basically cooking your brain cells. Obviously, these changes are very tiny. So once you take your phone off, your system automatically fixes it. But like I said, epigenetics varies. Not everybody can do it at the same rate. Somebody can fix it quickly, but some people's cells will not do that very immediately. They will lose these mechanisms. And that's how diseases occur. All diseases are alike in the initial state. And this is shown by a study in CSF fluid, the liquid that goes up your spine. முதுகெலும்பில் போகும் ஒரு 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 வண்ணம் இது CSF என்று அழைப்போம். அதில் வரும் மாற்றங்கள் இதில் காணப்படுகிறது. அதிகமாக நாங்கள் தொலைபேசியில் இருந்தபோது நடக்கும் சிறிய சிறிய மாற்றங்கள் அது புற்றுநோயை உருவாக்குறதுக்கு அறிகுறி. Most importantly, this is the last slide. Don't forget to smile. It's something that we all forget sometimes. Smile. The reason why I say this is, regardless of what happens in life, just a smile a day, as much as you can, and you'll see the change. You'll see that positive vibe that you bring in. And all diseases, just like I said, with the concept of evolution, whatever religion you believe in, all diseases are alike. In fact, the research that we're doing at the moment, it's progressing into Alzheimer's and diabetes, and we're coming up with new definitions. We believe now that diabetes is a form of cancer caused by insulin receptors, IGF, etc., with these metabolites. We believe that Alzheimer's is a form of cancer activity, oncogenic activity, that is based on beta amyloid receptors, etc. So we're going into new insights into research as we speak at the moment. So all diseases are alike. Now, what am I trying to tell you here? You need to take control. I've been mentioning the word control so many times. Take control. Take control. Take control. Thank you.
That was an amazing presentation. It's obvious that as a Tamil Canadian, he worked extremely hard to get to where he is today. So let's give him another round of applause. Putting hard work and dedication into anything you do is not easy. But achieving something out of the hard work and dedication is an accomplishment. To achieve something, one needs the right group of people to get there. More importantly, it's the person's duty to keep themselves from losing their interest and their love for what they want to achieve. It may take some time to find the right people and to reach that goal. But once you've gotten to where you want to be, there is no stopping. You will be loved, admired, and everyone will see you as a role model, or even better, an inspiration.
இன்ற பொழுதில் பெரிதுவர்க்கும் தன் மகனை சான்றோன் என கேட்டதாய் தாய் ஸ்தானத்தில் மகாஜன கல்லூரி பழைய மாணவன் என்ற முறையில் அல்ல மட்டுமல்ல தமிழனாக இங்குள்ள அனைவரும் அவரை வாழ்த்துகின்றோம். எல்லாம் வல்ல எல்லோருக்கும் பொதுவான ஆண்டவன் தமிழ் தாய் அவர்களுக்கு நீண்ட ஆயுளுடன் அவர் செய்து வரும் இந்த ஆய்வில் வெற்றியையும் அளிக்கும் என்ற அந்த உறுதியுடன் செல்வன் அபிக்குமரன் உத்தமகுமரன் அவர்களை மேன்மைப்படுத்தும் முகமாக அன்புடன் இந்த மேடைக்கு மீண்டும் அழைக்கின்றோம். அவரை மேன்மைப்படுத்துவதற்காக திரு சிவகணேச ஆனந்தன் அவர்களையும் அன்புடன் மேடைக்கு அழைக்கின்றோம்.
Ladies and gentlemen, the presentations, congratulations and applause to Abhikumaran and Uttamachandran on receiving the Governor General's Academic Medal in 2011 and on achieving an honorary doctorate of science from the English Montreal School Board. Thanks him for his participation in the Mahajana Award 2013 held on 5th August 2013, Mahajana College, USA, Canada. after listening to Abhikumaran's talk, my talk won't be interesting, I know. He's at young age, he's very, very inspiration to us. That's what we are here to celebrate. When I heard this story, I mean, a few years back, somebody told me there's a student in Montreal, 17 years, he got into medical school and he's doing some research. My first flash, I thought, I mean, it must be somebody, grandson of Albert Einstein or Louis Pasteur's grandson from France or something like that. I thought I didn't first see the story. After some days, they said, oh, he's an Asian boy. Then I was interested and I looked around and then I found he's from Sri Lanka. And my story got more and more interested. I was trying to read more and then the story, then we found that he is from actually a Sri Lankan Tamil. So that's what we are here celebrating. If he's a Jewish guy, we won't be having a party here. So this is a story of him. Here, what we are, a lot of parents here, grandparents here, youngsters are here. Everybody's dream is to become like Al Kumaran. I mean, he's brilliant. So, what we are doing is almost like selfishness like. But we shouldn't get scared about selfishness. Selfishness is, I mean, there's a book written by Richard Dawkins, says selfish gene. All these genes are very selfish. How can we have another Al Kumaran? I mean, we all love to have, I mean, everybody's dream is like that. He's brilliant, I mean, I can say that. But how can we have it? His work, this should be threefold. One is hard work. Everybody is prepared to hard work, but we can't achieve that. Then it could be environmental or somatic influence. The parents' influence, or parents are genius. Parents must be academics, very high academics, and every day giving tuitions at home and bringing up. Oh, the final one is the genetics. So this is interesting. Then I was reading more and more interested, and I found he has so much, I think, age 3, he did that, 5, he did that, 6, he did that, 8. Two things got interested me. At the age of 5, he started reading natural selection. That was amazing. I mean, when I heard about natural selection, it was almost 17 or 18 years. And before 17 years, my father is a teacher, he's a very religious man. He taught me the creation theory. Everything is God creation. But this natural selection is actually taught by our teacher, Mr. Kanagasawadi. He taught me for almost three months on evolution. But other interesting part was the robot theory. He did lots of interesting things. He went to Japan and did a robotic dance. And have you all read about it? He created a robot and he was dancing and when he dances, the robot imitated him. This is what in the movie Jeans, Aishwarya Rai danced. The robot was manipulating. Same principle probably. And he did something in Paris also, I think. He did another robotic show. And he did all these things. This reminds me that the movie Indran, where he created the city. Like that, he created so many robots. And so all these things, when we think back, now we can dismiss the hard work and the environmental, somatic influence. I was wondering whether it's the parents, all these did things. Then I found that parents are average people. I mean, mother is an average lady, is a housewife, and father is also working a normal job, and it's not the somatic influence. Incidentally, the mother studied in Mahajana, and her name is Kala Armugam, no? I think, yeah. Kala Armugam, I thought initially my classmate was Kala Armugam. Subhash Chandra's sisters, Kala and Armu, his father, he's a teacher, they are from Pannala, Talipala. Then I thought this is the same. Then I found that they studied later, 80s. So it was story was going on. I was getting more and more interested in him. So finally, out of the three factors, so all of us, the parents, grandparents, individual boys, girls, everybody wants to be like him. But the genetics is the important one. Probably genetics. So Kala, his mother and father, they gave genes for him. He has got, as he explained, he has formed from one cell, and he has 46 books here inside. And out of that, each book has 2 volumes, volume 1 and volume 2. Volume 1 is given by father from, he's born in Sundlipai or something. He's closer to Telipala. And mother is from Pannala. All these books are printed in Jaffna, in our area, closer to us. So these genes we have to preserve. So can we clone him? If we can get a copy of him, it's impossible. So we have to look for his, and genetics-wise, is something special. We have to protect him. And he's doing a big research in medicine, and that's a novel approach. It's a chaotic theory, and we listen to that, and it's very, very interesting. We always have a radiation, chemotherapy, or surgery and cut the tumor off. This is a totally different approach, and he should, all my best wishes for him to pursue and bring a new solution to this problem. Thank you very much.